Example 3. This is going to be the question that could definitely be on your test, something like this. We're going to say the height of a pool. Fine. Well, Thor is swimming in this pool. Okay. The height of a pool follows this data. And you're going to make a little chart here for time and height. I'm just going to alternate colors here just so you can follow the points along pretty good. So 0s with 14, 2s with 16, 4s with 17, 6s with 16, 8 is with 14, 10 is with 12, 12 is with 11. So I just alternated colors there for you. Okay, just so you could get this. Okay, we're going to get it out of the way. A is going to say model this with an equation. Yeah, you can put them left to right, and you probably should. I ran out of room though. B says use your equation. To find the first 4 times. The height is 15.2 meters. Okay, now I'm going to hit pause. All right. Okay, there's a few different ways you can do this question. Okay. Can somebody think of the first thing you can do? Because this one looks like a new style question here. It's the same as what we did before. How can we turn this into something we've seen before? What might be a useful way to start this? If you were able graph it might be a good idea. Okay, so take a second. This doesn't have to be, again, on your test here, Taylor. When you do this, this isn't going to be one where I'm going to say, this isn't going to be one where I say, 8 marks for this graph. This graph just has to be something to get a visual for how it's going to go. Time's going to be there and height's going to be here. Sorry, my sideways writing is good. Okay, so notice when I'm making this graph here, Georgie, that this isn't like a hugely beautiful graph, okay, even by my standards, all right? So this is just one. I made sure my y values had everything I needed. I took a look on here. 11 is my lowest, 17 is my highest, so those ones have to be on my graph. Left and right, I'm going from 0 to 20, so I got to get from 0 to 20 along the x or along the theta. Again, if I said to you, draw this graph, 4 marks, all of a sudden you're making a beautiful, perfect graph, that you can bring home and put on your fridge and show your parents how beautiful of a graph you are. Okay, but for this one here, this is just like a rough sketch to help you visualize this. This is an optional step. Okay, so for my points, I'm going to put these on here. 0 is supposed to be 14. 2 is supposed to be 16. 4 is supposed to be 17. 6 is supposed to be 16. 8 is supposed to be 14. 10 is supposed to be 12. 12 is supposed to be 11. 14 is supposed to be 12. 16 is supposed to be 14. 18 is supposed to be 16. And 20 is supposed to be 17. And if you take a look, that is a beautiful sinusoidal function, it looks like. Okay. Hopefully we can sort of see why that's might be helpful to you on this to draw a little sketch. Okay, hopefully everyone sees that now. When you're looking at this, this is hopefully going to help you out a little bit. Yes. This is where I hit pause and shoot down the student. No, I will not do that.
You shoot us down.
Never. My life. All right, here we go. So for this here, we're going to try and get some information here right now. Okay, I'm going to go back through the end of the time. So we'll go to Victoria here. Victoria, on this graph, what's the max and what's the min, please? Yeah. Now, once again, you could have gotten this just from the table. So if you're telling yourself, Mr. Sal, I want to save time, you can get that from the chart, and that's okay. But you can also get it from the graph very easily. All right, Cody, be brave here. What's my axis going to be? 11? No. I'm going to go with, oh, wait. Yes, but no. Okay, the axis, right, remember, is the difference, the average of your y points, right? So you're going to take the highest and the lowest and divide it by 2 to get the average. So the highest here is going to be 17. The lowest is 11 divided by 2, which is 28 over 2, which happens to be 14. All right, Kayla, I also want you to be brave and to try and get the amplitude for me, please. Very good. So it's going to be max minus min over 2, which is 17 minus 11 over 2, which happens to be 6 over 2, which happens to be 3. Okay? So again, just the same stuff. Once you know how to do this, again, it's all the same.
That's right.
2000, that's a game, isn't it? IQ 2000. This is how it is my IQ. Why am I taping this? What is my IQ? Remember? Grade 3, that's my. You can't Google it anyway. Let's leave that right now. Okay. All right, Emily. What else do we know here? Let's maybe do the period now. What's the period for this graph going to be? Yes, it is. It does go from 4 to 20. So 4 is your first point. That's your period. And that goes to 20. So that number, we're going to call that actually 16. Right? Because it's right 4 on the left, 20 on the right. 16 is what you're adding to each time. Okay. So again, just think, if this is this beginning is 4 and your ending is 20, it's going to repeat every 16 units. 20 minus 4 is 16. Okay. All right, and Noah. Phase shift. Noah, phase shift, please. It's going to be what? 4. Very good. Very good. So that's just your shift is going to be there. Always cosine you're going to use, because again, this one again we had a 14, but in a lot of cases you're not going to have a point right on the axis. Let's say this is 13.8 I did instead. You wouldn't be able to find the exact value for it. Okay. So my phase shift is going to be 4 units, right? All right, Georgia, you're up. What's my K value going to be, please? How'd you get that? Yeah, 360. Yeah. Yeah. Is 22.5%? Okay, Alex, you're the lucky person. Can you please give me an equation for this if you'd be so brave?
Y equals 3.
Yeah. Yeah. Actually, I have a minus 4. Because remember, like a positive shift is a minus, yeah? Very good. Now again, the only way I might change this, that's fine for an equation. Can someone think of something I might do to change that? No, that's over the 22.5 is okay. Well, the only thing we're talking about height and time. So if you want to, you can also say count time as your, you know what I mean, as your x's and h's your y's. Okay. I'm probably not going to be too picky on this. Okay, I'm not going to be too picky on this. But the thing is, since we're talking about time and height for the word problem part, it's probably useful to write your equation in terms of time and height. All right, letter B. Angela, what are we doing for letter B? I didn't write that down. That's okay. Okay, so for letter B, it says use your equation to find the first 4 times the height is 15.2 meters. So when we're looking for the height to be 15.2 meters, what do? Very good. So we're just going to say here h equals 15.2. And again, if you use this equation here with y, you just say 15.2 equals, but again, it's good to do in terms of h and t. So I'm going to say 15.2 equals 3 cos 22.5 t minus 4 plus 14. Okay, and I'm going to hit pause right now.